Hello and welcome back to Quantitative Reasoning Online. We're going to do this video is going to do the tutorial for Part 4B preview assignment. So with no further ado, let's start the tutorial. Again, I have to size it up properly. All right, let's see. This tutorial will, determine the probability of a single event, determine conditional probability with dependent events. Okay, so let's go on, let's continue. Lesson 4, Part B. In this class, you will compute probabilities of dependent events. Some background information will help you prepare for the lesson. The tutorial begins here. Okay. Review the prompt and enter response in the box. Okay, see, a bag contains 10 balls, 5 are green, 4 yellow, 1 is red. If you draw 1 ball from the bag, which of the following is true? Let's see, probability of event A happening is number of ways A occurs, number of all events that are possible. So let's see, probability of A. How many events are possible? Well, we have 10 balls. So there are 10 possible events. 5 events are green, 4 events are yellow, and 1 event is red. So it depends what you're looking for. Probability of pulling a green ball, probability of pulling a yellow ball, probability of pulling a red ball. In each case, for the first drawer, there are 10 things that can happen. Then for green, let's see, for green, there are 5 green balls. For yellow, there are 4. And for red, there are 1. Because there are 5 ways to pull a green ball, 4 ways to do a yellow ball, and 1 way to do a red ball. So let's see. Part A, each color is equally likely to be drawn. Well, by what we've just done here, well, that rules out. Okay, there's a 1 in 2 chance of drawing a green ball. Well, reduce 5 over 10, that reduces to 1 over 2, or 1/2. Okay, possibilities. 1 in 5 chance of drawing a green ball. No, there are 5 chances to draw a green ball, but 5 chances out of what? Out of 10. So it has to be B. So B, 1 in 2 chances. Yep, there we go. So now let's clear the screen here. So again, probability of any event A, number of ways A occurs. So probability of pulling a green, there are 5 ways it can occur. Probability of pulling a yellow, 4 ways it can occur. Probability of pulling a red, 1 way it can occur. Number over the number of all events possible, well, in each case there's 10 because there's 10 balls to choose from. So a bag contains 10 balls, 5 are green. Hey, same as before. So if you draw a single ball from the bag, there is one, and how many chances of drawing the red ball? Okay. Probability of drawing a red ball is 1 chance in 10. Let's go check. Oops, here we go. 1 in 10. Chances of drawing a red ball. Yep. One in 10. 1 in 10. Got that one right. Okay, question 3. Event B is considered to be dependent if the outcome of event A affects the outcome of event B. For example, consider the bag of 10 balls in the earlier question. Remember, 5 are green, 4 yellow, and 1 is red. Now, what it's saying here is we have 2 events going on. Does having done event A affect event B, or does event A not affect event B? And depending on whether it's independent or dependent. Okay, so we'll get there. If you draw a green ball from the bag and set it aside, part A, how many balls are left in the bag? Okay, I start with 10. If I take one out, I should have 9 balls left. Okay, now drew a green ball out. I started with 5 greens. 1 is now gone. So now there are 4 greens. How many are yellow? Remember, we drew a green ball. So start with 4. I'll still have 4. And I also have 1 red. Nine, 4, still 4, and 1. So let's look at this one. Probability of a green, we said would be the number of greens over total number of balls, or 1/2. Okay. This was event A. Now, if we say event B, well, probability of pulling a red. Well, how many reds are there? 1. Except now, we took out a green. How many numbers of balls are left to pull? Now it's 1/9, 1 over 9. Okay. So right now, the probability of event B is dependent on event A. Because event A, we pulled out a green ball, which reduced the 2 things. It reduced the number of greens there are, but it also changed the denominator from one event to the next. So keep that in mind. Okay, 5 green, 4 yellow, 1 red. But you remove 1 green ball from the bag and set it aside. Draw a second ball from the bag. What's probably that it is red? Oh, just did that. So we had 10 minus 1 to 9 balls in the bag. Still have 1 red ball. So probability of now pulling a red, well, again, How many ways can we pull a red ball? Just one. Over how many ways of total ways of pulling a ball is 9. So 1 in 9 chance. So it appears to be C. Got it? So what now? So now we go from, now we have 8 balls left in the bag. We have 0 red balls. So now, what's the probability of pulling a red ball out? Well, there's 0 chance of getting, there's 0 red balls left. Zero. Just for extra information. Okay, what's the next question? Okay, so first ball drawn is an independent event. So the first event is always independent. Let's see. When the ball is not replaced, big concept, replacement, not replacement. The second ball drawn would be dependent upon the first event. More formally, we can describe the probability as a probability of event B occurring given that A has occurred. Or in shorter form, probability of B given A. And shorthand, that's how we show it. And we give the name conditional probability. Now, can we make this conditional probability to be independent? Yes, we can. If we keep on replenishing the pool, we pull out a ball, we pull it back in. Okay. So what this replacing does results in always keeping the denominator constant. So the probability is always being done with the denominator being the same. It makes every single probability an independent event. So keep that in mind. If you're doing probability with replacement, it makes each event independent. Okay, hey, a little grading here. How confident are you that you can determine the probability of a single event? A single event, I am extremely confident. How confident you can determine conditional probability? Extremely confident. Okay. Just keep track of the denominator. Of the probabilities, of course. All right. Preview what we've done, probability of a single event, and we determine conditional probability with dependent events. That's what we did, and we're done with lesson 4. Complex numerical summaries, graphical displays, lesson 4 summaries. Well, lesson 4 tutorials. Next video will be going over the questions for lesson 4B tutorial. I'll see you then.